Hello, hello. Good afternoon from Vienna in Austria. Good evening, good morning, wherever you are in the world. Hope everybody's having a wonderful day. And welcome to March's Suborbital Community Meetup. I'm Ramon. I'm super excited to be here today. Just realized I got to take off this banner that says we're starting soon because we're already live. Yeah. How exciting to be here. This is my first time hosting this. I'm nervous, but I'm excited. If we haven't met yet, hi, I'm Ramon. I'm a developer relations engineer here at Suborbital. And yeah, let's dive right into what we're having this month. So we'll be having 3 presentations today. I'm super stoked about these. First, we got Laura from Suborbital, who's going to join us here in a few moments to talk to us about some documentation updates at Suborbital. Next, we've got a special guest, which is Philippe. Philippe, I'm sorry if I'm saying this wrong, Philippe. You'll correct me when you come live. Charrière? Close, I hope. Who are going to do an AMA and Ask Me Anything. We're going to talk about his WebAssembly journey, how he uses SAT, which is one of our projects, and his book, Wasm Cooking with Golang. So stick around, that's going to be super fun. And last, we're going to have Connor, the founder of Suborbital, who's going to come on live and give us an update on SAT and Consti and how he uses this to create what he called the little WASM server that could. This is going to be super fun. Folks, just so you know, I'm going to be emceeing. Please throw your comments, throw your questions into the chat on Discord, into the community meetings chat channel. We'll be keeping an eye on it, and any questions that come up, especially during our AMA, please bring them in and we'll answer them accordingly. So without further ado, I'm going to bring on Laura to kick us off. And yeah, super excited. Here we go. Hey, Laura, how are you? Laura, I'm going to need you to unmute yourself, please. I'm sorry.
Cool. Hello, I'm Laura. I'm a technical writer here at Suborbital. I've been here for about a month. Actually, my very first day working was the day of our previous community meetup. So this is kind of a full circle moment for me. So I'll be writing or talking today about some updates that we've made to our docs in the last month or so. So I will get ready to share my screen here.
Wonderful. Thank you so much. I'm super excited to see what the updates are.
Okay.
Yeah, we've been working like last month we had the official launch of the new docs, and ever since then we've been pretty much working super hard in the background. I'll let Laura update us more on that. What am I doing? Spoiling everything. Sorry.
Okay. I think I am successfully sharing this time. Is that right?
Yes. So
okay,
I've got you. Yeah. I'll let
yes,
you. I'll tell you what, Laura.
All right, and I will
fade
get
into the
those out of
background.
everyone's faces. Okay, so first we're going to talk about our multi-language code blocks, courtesy of Fluffy. We now have the ability to display code snippets and code blocks in multiple languages in tabs. And so, for instance, here's our runnable API landing page. And we've got this first runnable that we can show in Rust or in JavaScript or TypeScript, Go, assembly script, Grain, or Swift. Not all of our runnables are supported in all languages yet, but you can tell which languages have which levels of support because we've got this handy little banner. So Swift is in preview status, and assembly script is in beta, Rust is in stable status. And we also have some information about how to interpret each of those support status levels on our language support page. So we've got a chart here that shows where each language is in terms of its support status. So these are synced, so that these will automatically update when these statuses change. We also have some information about the compilers for Rust and Go. We'll be adding a lot more information to this page with compiler information of our various other languages. So, where are we here? Where was I? Okay, yep, and right, okay. So we're also adding some pre-built runnables to our runnable API docs. And so these runnables will live in our test databases. So they'll be going through continuous integration type checks. And so these will be constantly maintained and kept up to date. So these will serve two purposes. One, they'll serve as example code so that people can get a feel for what the code should look like for a runnable in, again, all of our handy dandy different languages. We can see on this page, we've got these methods, these HTTP requests, but on some other pages, we don't have all of the languages available for different options or different methods, rather. And the other purpose that this serves is that eventually these will act as so that people don't have to reinvent the wheel every time you want to you need a runnable to perform, say, a URL, return the full URL of a request. You don't have to write it yourself. You can just use it because it's already here. So that'll be nice. So that's something that we're working toward right now. We're just in the early stages of that. And thanks to Ramon, we now have a glossary for some of our WebAssembly and Suborbital specific terminology, and we'll be building this out as well. So if ever you're looking through our docs and you're thinking, what exactly is a handler or a directive, you can just look that right up in our glossary under Atmo concepts. So that is super cool. And finally, in April, we will be having our first book club. And the book that we're going to read first is Docs for Developers. There will be more information posted next week, I believe, is the first week of April. We have a book club channel in our Discord server. And so if you want to join us to read Docs for Developers, we will be getting started on that next week. And finally, I will be starting a lunch and learn type of stream on Twitch to sort of show a workflow for editing docs, like looking at the process of looking at the open issues and choosing one, editing it, pushing the changes, and so on, to give aspiring contributors a complete preview of how docs contributions can work, because I know that before I started at Suborbital, I was really not sure how this would work. And so I didn't have the confidence to just jump in there and start working on someone else's docs. But if I had had a preview of what that would sort of could look like, I would have had a lot more confidence. And I would love to share that with other new contributors. So I will be sharing details about that probably also next week. Maybe I can even get some of the dev team to join me sometimes to show non-docs type workflows. And that's it for me.
Thank you so much, Laura. That was well exciting. Let's bring the slides back. Hey, yeah, that was super cool. Thank you. And I love that you're gonna, so Laura and I have been doing some streaming the past month, doing some WebAssembly together. So I'm really excited to see that we're gonna be moving beyond that. You're gonna be doing some streaming of your own. And do you have a channel that we can put into the chat here?
I do. It does not have a stream set up yet because I hadn't worked out like dates and times and so on. Let's see. So that would be, yeah, I'll drop it in the chat.
Fantastic. Thank you so much. Yeah, no, and I also dropped the link to the books, to the book, Docs for Developers, if you want to join in and read along with us. I joined a read along last year, and this is a great book, so I'm super excited. And yes, there's a book club channel in Discord that you are absolutely welcome to join in on. And yeah, let's write some doc stuff together. How exciting. Cool. Sorry. Anything else you wanted to leave us with, Laura? Anything I might have forgotten about docs?
Nope, I'm all good. Thank
Fantastic. You. No, well, thank you so much. And yeah, I will move us along to our next topic. So I'll say goodbye, Laura. See you next time. And yeah, wasn't that wonderful, folks? I'm super excited to be bringing on our next guest. So I'm about to bring on Philippe. Hello, Philippe. Fantastic. Welcome. So good to have you.
Everything is complicated today.
All good. All good. There we go. It's the two of us here. Welcome, Philippe. Nice to have you here.
Just wait a minute.
Take your time.
I hear you, but it's very, very, very low. Speaker.
My volume is low? Take your time. Like we've got a moment to get started and just have a friendly community chat. And folks, if you've read the book and you've got any questions for Philippe, please absolutely start, putting them into the chat. And I will happily read these out to Philippe. I'll put a little thing here at the bottom so that if you're watching this afterwards, you can catch it as it goes as well.
I cannot hear you. It's very, 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 very low. Perhaps wait. I will try again, please.
Yes, I'm still here. Is that better?
Okay. Why is it so?
Absolutely.
Audio. Logic. I think it's okay.
Hello.
Try again.
Yes. Hi. Hi.
I'm almost here.
You almost hear me.
Yeah. Sorry. It's okay.
All fine. Yeah. Great to have you. I'm getting some feedback. How about we try that when I'm if you don't mind, Philippe, I'm going to be a little bit rude and strategically mute you. I don't hear myself anymore. This is great. Okay. Hi. I've been so excited to have you on, Philippe. So I'd love to get some background on you. Could you please tell me a brief introduction to yourself, your pronouns, and what you're working on nowadays?
Okay. So thank you for inviting me. I'm a little bit nervous, but it will be okay. My name is Philippe Charrière, and you say it very well, so thank you. As you can hear, I'm coming from France, and I'm working for GitLab as a technical account manager. In fact, I'm helping customers with their adoption of GitLab. And I'm living with my significant other and two teenagers, a girl and a boy. And what else? I love coding, cooking, biking, and a little bit drinking too.
Well, that's lovely. I'm really thankful that you come to join us today and talk to us a little bit about what you're working on. I think it's really, when I had a chat with you last week, I got really inspired by how you share your learning and how you get motivated to do so. So I'm curious to know what your introduction to WebAssembly was. But before you answer that, folks in the chat, please, any questions that you have for Philippe, drop them in, and I'll be around to bring them over. So yeah, I'm curious what your introduction to WebAssembly was.
At the beginning, it was probably because of microservices and function as a service. Some years ago, 4 years ago, I think, I was working for a PaaS company in France, and I always been amazed by the fact that a lot of customers use many resources with virtual machine or containers for simple microservices. And then at this moment, I discovered OpenFaaS from Alex Ellis. It's a PaaS and a FaaS at the same time, and you can run it even on a Raspberry Pi or on a huge server. It was a kind of illumination about function as a service, and at the same time, I started to develop my own platform, but only with a Java virtual machine, without any containers. It was only for learning. I did several versions with pure Java, with Scala, with Kotlin. It was like exercise. And then I discovered WebAssembly, and it was finally for me a bit like the JVM, but lighter, and with no security issue, because you cannot do a lot of things finally with WASM module. So for me, it was easier to implement something.
That's great. We're getting some questions already. I'm quite excited to bring them in, if I may. I've got a question from Connor here, who's asking what part of learning WASM from scratch has been the hardest?
In fact, it wasn't at the beginning. It was last week. I will try to explain. I started to look seriously at WebAssembly during my summer holiday last year. I started with Rust, and finally I discovered that my learning curve will be easier with Golang. So I started to learn Golang and WASM at the same time in the browser. And finally I said, yeah, it's not difficult. And there is a nice support of WASM with Go in the browser. And last week, I had a fight with the host function, in fact.
With which function, sorry?
The host function.
Oh, yeah. Yeah, the host, right.
And I knew what were the host functions, but I never played for real with it, because in the browser you have everything you need, so it's not a problem. And I started some experiment last week for a talk in some weeks, and I discovered that host functions are very, very difficult to use. So I had the solution by using Reactor or SAT or Atmo, but I wanted to do it from scratch and with an edge, and finally I didn't succeed. So yes, for me it's the hardest part, and perhaps there is another one. If when you begin, it's how to pass a string as a parameter to a WASM function. But I've found some samples. In fact, with Golang in the browser, it's easy. You almost do JavaScript with your Golang code, so it's very easy. And after I started to play with Atmo and SAT, so you have it directly. And I didn't understand at the beginning that it was in fact not simple at all.
Interesting. Thank you for answering that. So I got a question here from eLewis787 on Discord. Will we see another WASM cooking for any other languages? I love the ebook.
Okay, so if you love the ebook, I'm very happy because we will speak about it after, but it was a lot of challenges for me. Yes, I plan to do another one probably in a different way, but it will be a recipe like the first one with Rust, I'm sure. Probably I will try to do some C, but I didn't write C code since 1995, so it was a long time. But with EM Scripton, there is a lot of very interesting things. And I plan to dig more with Gren. So at least 3 languages, perhaps more, we'll see. I will start probably during the summer.
That's really exciting. Yeah, I'm curious to know what it is that that got you interested in sharing your like how it is that you got into sharing your knowledge like this and going into Oscar in Discord is quite excited about the grain use. No, I'd love to know like how you got into sharing your knowledge and writing books and stuff.
It was a long time ago. I think it was 70 years ago. It's the age of my daughter. I was a technical manager, and I have probably lost all my technical skills. And it was difficult to ask technical things to the team, for example, when you don't understand anything, in fact. So I decided to learn again, and at every new lesson, or everything I learned, I wrote a blog post to share what I learned. It was my first blog, probably, and since that I never stopped. So when I started to learn WASM and Go, I wanted to do the same thing naturally. It was, in fact, I started that in the summer, as I said, and at the same time, Connor pinged me on Twitter. I was very surprised, asking me to write a blog post about my beginnings. So I think I start by saying, "Are you sure?" And then I say, "Yes, okay, with pleasure."
That's wonderful. That reminds me, I'm gonna post that that blog post into the chat here, and of course into the notes. But that's wonderful. So and you've been, if you don't mind, if you don't mind my asking, you've been writing a lot in both English and French. Is that correct?
Before working at GitLab, most of the time I use only French.
Yeah.
And when I started at GitLab, people were so friendly with me about the language, the foreign language, that finally it was easier and easier to write in English about technical stuff, of course. But so I decided to try to write the most as possible in English. It depends. If I had a very long night with friends, with beer, and if I didn't sleep enough, I will write in French the day after. But yes, for the technical part, it's easier to write in English because even in France, we use English words to speak about technical stuff. And yes, it was a challenge too.
That's wonderful. Thank you. And I think that's really inspiring. I recently myself started writing more in Spanish, for example, and it's a challenge. Technical English is so prevalent that, especially when it comes to these technologies we're working with. But yeah, we got sorry. Got a question here from Naya on Discord asking, Can you tell us about your inspiration? Oh, that covers a lot of our faces. Can you tell us about your inspiration for writing this specific ebook? Was there something you see in WASM or the future of WASM that you thought was especially interesting and necessitate, writing this book?
Okay. What the most interesting part for me is not WASM in the browser, but I think it's essential because it was the beginning. But I'm a former JavaScript developer, and I think that we already can do amazing things only with JavaScript. But on the server side, I think WASM is a solution for a lot of things about security, about computing, and about doing small things, in fact, on a small computer, for example. Right now, you want to write a microservice in Java to get the list of, I don't know, restaurant or something like that. You need a container or a virtual machine. You need a framework. You need a lot of things. With WASM, you need the same, but it's lighter, and probably it's quicker too. I didn't do real load test. It's my next step in my WASM discovery, but I think the future of services and probably edge services is in WASM.
That's really exciting, and I very much appreciate you answering these questions. I'm curious before we. If there's anything else that I'd love to know if you've got, for folks that are looking into getting into WebAssembly or getting into sharing content, if you have any advice for folks who are interested in either of these parts.
I would say I did a simple certification last week, I think, on the edX platform. I will put the link in the chat after. And there is one, the training is free. You pay only if you want the certification, but the training is free. And on the platform, you can find 2 certification or 2 training. And I think the most interesting one is Introduction to WebAssembly. It's very simple, but it explains very clearly, even for a French guy, the plus of WebAssembly and the issue you can have about host function, for example. So I would say try this first, and after read the documentation and the blog post of the WASM project. I don't know if they did the best of breed of runtime implementation with WASM and WASI, but they have a very clear documentation and a very understandable example, and it's very important.
That's great.
And the last step, I would say, start playing with Atmo and SAT. I don't know if you should start with Atmo and then SAT or the reverse. I start with Atmo, in fact, but it's a good way to start without. It's the soft. It's like Kubernetes. You have the hard way. It's, for example, WebAssembly from scratch, and you have the software with Atmo or SAT, because you can start something easily without thinking about difficult thing. And as the runnable are polyglot, you can even starting to learn Rust or Golang or something else. So it would be my advice to getting started with WASM.
That's fantastic. Thank you so much, Philippe. This has been really, really wonderful to be able to talk to you and learn about, learn about how, you got into this, how you, for me, a lot of this learning of learning and getting comfortable in technologies is about stepping out of my comfort zone. And that's something that I find very inspiring and very much appreciated.
It's what I did when I write the ebook.
Yeah.
Because it was a triple challenge for me. I'm not fluent in Golang, but it's easier than Rust, I think. I'm not a specialist in WASM. And the last one, I'm French, and I did it in English. So, but I learned a lot of things. I had the chance to show my work to Connor, for example, and he gave me some advice, some friends too. So it's a very nice exercise, and I think whatever the topic, everybody should try to do this.
Yeah,
it's a good exercise. In fact, I have no memory, so in fact, I use my ebook almost every day to find some samples, etc.
That's really handy to know as well. Yeah, thank you, Philippe. Before we let you go, any way that folks can get in touch with you if you like?
Excuse me, I
I'm
didn't
sorry.
the last sentence.
I misspoke. If folks would like to get in touch with you, how would you recommend that they?
Okay.
That they do?
They can reach me on Twitter. I think it's the best way. I'm Twitter addict, so it's not too difficult to join me.
Wonderful. So I'll post your social there, and then folks can go and get in touch. I hope if they want to talk about writing, WebAssembly, and Golang, and maybe Rust soon.
I'm pretty sure I will use Rust. In fact, in April,
Yeah.
20 of April, I think, I will do a long talk with of 3 hours with a friend of mine about WebAssembly at a conference in France. The name of the conference is DevOps. At the beginning, it was a Java developer conference. It's probably the biggest developer conference in France. And we propose a long presentation about WASM, and there will be Golang, of course, Rust, Grain, Suborbital, and a lot of things.
That sounds wonderful. Great. Well, thank you so much, Philippe.
Thank you to you.
Oh, this was great. Let's do it again soon. I hope.
Of course.
Sounds good. Listen, wish you all the best. Have a wonderful evening, and thank you once again.
Thank you. Bye-bye.
See you later. All right, folks, we are chugging along great. Thank you all for sticking around for our community meetup. We got one more presentation for you today, and that's from our founder, Connor, who I'm bringing on now. Hey,
Hello.
Connor.
How's it going?
All good here. All good here. All technical issues superated, I hope.
Seems that way.
So, yeah, thank you for coming on today. You're going to tell us a little bit about what you've been up to with SAT and Consti.
Yeah, absolutely.
Cool. I see here you're sharing your screen. Is it okay for me to bring it up?
Oh yeah, go for it.
Wonderful. So here we go, and I'll let you take it away.
Sounds good.
Folks, if you want to ask any questions in the chat, please feel free. And yeah, see you right after.
Alrighty. Hello. So I want to talk a little bit about SAT. It's the newest project in the Suborbital family, but it is one of my favorites because it is just so incredibly simple. It's something that we built in the later half of 2021 to address a couple of needs for our suborbital compute product, but it has turned out to be a very wonderful standalone open source project of its own. And the original problem we were trying to solve is that when somebody is writing a function in the suborbital compute code editor, we wanted them to be able to run a test. So we wanted them to be able to build their function and then give it some input and test its output. And so we struggled with this a little bit because suborbital compute uses Atmo to run the deployed functions in production, but we weren't really sold on the idea of running a completely separate cluster of Atmo instances just for running function tests, because we thought, these are going to be relatively low traffic in comparison, and it's not really worth the compute to stand up an entire second cluster of Atmo instances. And so the solution that we came up with was, okay, let's create something that can just start up, run a function, and then terminate itself. And that was the basis for SAT. Now it's evolved quite a lot since then. It has a whole bunch of different operation modes, and I'll go through a couple of those today. But it still has that base capability of just very quickly running a function and then quitting. And what it has evolved into is what we like to call a tiny WebAssembly edge compute server. Oh, this is not agreeing with me here. There we go. Yeah, so we call it a tiny WebAssembly edge compute server. And the reason we have chosen to talk about it in this way is because SAT is a whole lot more lightweight than Atmo. Atmo is designed to take an entire application, which could be comprised of many, many functions all collaborating together. And it runs them all at the same time. So when you start up Atmo, it loads all of the functions for that application into itself when it starts up, and it coordinates their operation all within the single process. But SAT, on the other hand, it takes a completely different approach, and it instead just runs one single function. And because it doesn't need to concern itself with loading multiple functions and coordinating them and blah, 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 it just has a lot less going on. And so it's a lot more lightweight. It can start up extraordinarily quickly. It can serve a really large amount of traffic all by itself. It can mesh with its peers. So as I'll show in a couple of minutes, you can still run entire applications using SAT, just in a slightly different way. And it's also zero config. So that's kind of where I'll start. Zero config is one of my favorite parts about SAT. With Atmo, you have a directive.yaml that you use to describe your application that has some config. It has all of your different routes in it, and you kind of that's a required piece of the puzzle, and so it's something that you need to author as the person building an application. But with SAT, you don't have any of that. So if I just run SAT and I pass it the path to a WebAssembly module like this, that's it. I just run SAT and I point it at a WebAssembly module, and it says, "Okay, cool. I'm gonna do my best." Now there is optional configuration, right? So as you can see, it chose a random port to start up on. So if I wanted to instead choose the port, you can do things like choose the port, right? So you can optionally add some configuration to make it work exactly the way that you want, but it is zero config by default. So we've got SAT here running this hello echo function. And if we take a look at what that function looks like, it is exactly what it sounds like. It is echoing back whatever message you send it with hello. It's your standard hello world. So I'm just going to close my sidebar, and I'm going to split my terminal in half here, and we're going to send a message or an HTTP request to SAT, and we'll see that there you go. It's running that function, which is SAT's basic use case. This is an extremely easy to use, extremely fast, extremely lightweight HTTP server for WebAssembly. And this is all you need, really, to stand up a production-grade WebAssembly server. SAT can automatically get TLS certificates for you. It can handle huge amounts of traffic because it can auto-scale internally. It can have many, many replicas of that WebAssembly function handling traffic within one SAT instance. And it can be deployed as a static binary. That's one of the big benefits of having this kind of small, compact server configuration, is that it is a static binary. It doesn't have any dependencies, and it can run in a Docker container that is distroless. So it's based on the absolute smallest Docker image that you can possibly get. And this is really useful for standing up all kinds of different services. We have things like collecting metrics. You have things like file servers, and you have things like being able to do like counters and rate limiters and like session checkers and all sorts of different things that they end up just being one endpoint at the end of the day, and so you can deploy them just with SAT all by itself. So that's SAT's basic use case. And there are kind of two other modes of operation that SAT can operate in. So this is what we call server mode, where it's just a regular HTTP server. The second mode is what we call standard in mode. So I'm going to get rid of that terminal, and we'll try standard in mode. So this was a server, and it uses HTTP to send to respond to messages. But SAT is also really useful for just doing one-off tests. And this is similar to how it operates for running function tests in suborbital compute. So if we run an input like my friend, same as we were doing with HTTP, and we pipe it into SAT, and we want to do standard in, and we want to use that exact same hello echo function, you'll see that that's it. It's just start it up, take it in the input, run the function, and then quit. Now the function does some logging, which is why you're seeing a little bit of extra output here, but this is the actual response of the function. So you can do things like local testing, you can do things like one-off CLI type operations, and this is really useful for just, you have some code that you've written and you want to test it out really quickly. This is really nice. We use it for a bunch of like integration testing and stuff. So that's operation mode number 2. Operation mode number 3 is the coolest and the most complicated, but possibly, the most important mode. So the third mode is what we call meshed mode or constellation mode. And it uses something called const, which is also in the SAT repo, to run a whole bunch of SAT instances together in what we call a constellation, which is a meshed group of instances. And these meshed instances can all communicate with each other. And what we can do with this constellation is emulate Atmo, but at a much more distributed scale. So I'll give an example, and there is an example project in the SAT repo under const where you can try this out for yourself. But you'll see that this example project has that directive.yaml, which is the staple of an Atmo application. And you can see that it is identical to an Atmo application in every single way. That's because it is. So we can define different endpoints, right? We can have multiple functions chained together. We can do all the same things that we do with an Atmo application, but we're going to run it on a whole bunch of sats instead of a single Atmo. So there's a make target in here to simplify setting all this up. So if you run make const /metal, this will run const with the metal executor. So this means that it is running sat as just a binary on your machine. It's not using Docker. So there's also a const /docker if you want to use Docker containers instead. And so what you'll see is that it's going to build this tool called const, and then it's going to start up a flurry of activity. And all of this is the constellation building itself. So the constellation essentially runs a pool of sat instances for every function in the application, and then it runs something called Atmo proxy to kind of handle the requests that are coming into the constellation. So you can see here that it is in fact running all the sats, one pool for each of the functions that you find in the example project. And it is also running Atmo proxy, but I highly doubt we will be able to find the log message for that. So I will split my terminal again and I'll run ps-a, and you'll be able to see Atmo proxy and a bunch of sats running here for the entirety of the application. And I'll close this again so we get a little bit more space. So as we had defined in our directive, we have the /hello and the /goodbye endpoints for this application. So if I go ahead and do the same kind of request, instead of curling just to the localhost 8080, instead I'm going to send it to /hello, because we now have a couple of different endpoints that we can hit. So immediately you see this returns. It looks like it's doing the same thing as just the sat instance by itself. But what actually happened is that Atmo proxy received the request, found a sat instance in the constellation that could handle the request, and then it actually asked that sat instance that was loaded the hello world function to do the execution. And then it all returned. And so this is really cool, but it's essentially doing the same thing as one sat by itself. So maybe not that interesting. Where it gets a little cooler is when we look at this second handler and we have the goodbye endpoint that chains two functions together. So we have that hello world RS function that we looked at the first time, but we also have a goodbye function. This one happens to be written in Go, and it's complaining because I don't have the TinyGo extension enabled right now. But the goodbye function written in Go does something similar to the hello function, but it says goodbye instead. And if you are familiar with Atmo, you'll know that when you have several functions in a chain like this, it will execute them sequentially, and it will return the output of the last function in the chain. So we are going to give that a shot. If we send that curl request to /goodbye instead of /hello, and I will close this again so we have more space, you'll see that we get the goodbye response. And this is a little bit more interesting because even though the Atmo proxy received that goodbye request at the beginning, it then chained the execution between multiple sat instances. So it went first to the hello world function, and then it went to the goodbye function, which were running in two separate sat instances connected by a mesh. And this allows us, this basically gives us all of the building blocks to execute any Atmo application that exists. And all of this is done by constantly managing this constellation. So there are, it starts and stops all of the sats that you need, and it will auto scale them to really absorb a lot of traffic. So to show that off, I'll use the Hey tool to do a little miniature load test here. So what we're doing is we're using Hey, which is a load testing CLI. We're going to have 20 concurrent clients. We're going to send that same payload. We're going to send a post request, and we're going to do 10,000 of them, and we're going to send it to that hello endpoint. So you'll see just an absolute frenzy of activity on the left, and you'll see that a bunch of stuff happens after all the requests are done with. And what's going on is that when the constellation gets a big burst of traffic, it's going to expand. It's going to auto scale in order to handle that traffic. So I'm going to attempt to demonstrate that by pulling another terminal window over here. It's getting a little crowded, but hopefully we can get all of this on the screen at a reasonable font size. So I'm going to watch the PS function to show the different processes running on the machine. And we're going to try to demonstrate what happens when this auto scaling takes place. So I'm going to do the same load test again, but instead I'm going to do 100,000 requests because we want it to last a little longer. And then I'm going to quickly flip over to the other terminal so we can watch what happens. So I'm going to launch that and switch over. And what you'll see is more sat processes are being added as these gigantic request flurries are being handled. And you'll see my CPU is going wild because it is distributing this load across all the hardware that it has available to it. And this window is a little bit too small. I can't actually scroll all the way to, maybe if I extend this down a bit, yeah, you'll see that there's a whole bunch of them that have auto scaled to handle all of this. And at the end, once this is done, when it's printing to console like that, it's a little bit slower because it has to handle all the printing. But there you go. As it finishes and you see that we got all of those responses back, you'll see that this starts to contract again. So these SAT instances start going away, and because they're no longer needed, there's no longer much load on the system, and so we are left back with just one SAT instance for that hello world function. So that is the third method of operation for SAT, called constellation mode or mesh mode. And so this extends itself to a pretty awesome scalable architecture. And I know we've only got 2 minutes left, so I'm going to wrap it up, and then Ramon can come back on and tie up the whole meeting. But the idea here is that SAT can run many meshed instances in a widely distributed manner, and this allows us to essentially infinitely scale any application. And because we believe that WebAssembly on bare metal is the best way of implementing edge computing or edge functions, we think that SAT will be the vessel that gets us to this future version of the edge that runs WebAssembly. And we're going to have lots of news related to that in the next couple of months. So keep an eye out for that. That's all for me.
Awesome. Thank you, Connor. I hope I didn't cut off too much of your time there. This was fascinating to see.
Yeah.
Thank you very much. Do you got time for a couple questions?
Sure.
Yeah, cool. Got one from Philippe actually on Discord, asking, is it possible to add dynamically a SAT service to the constellation?
Yeah. So this is a more advanced feature, I guess, that is not yet well documented, but it is something that we can do, and we have been able to do. We are kind of testing this internally right now. Everything within Suborbital is able to communicate using something we call an app source. So an app source is a set of APIs that allow the thing running WebAssembly, like SAT, to pull all of its configuration down from some external place that we call a control plane server. And so using a control plane server, which is not yet available, but maybe will be soon, you can dynamically change the constellation in a bunch of ways. So you can deploy new versions of functions, you can roll back functions, you can deploy entirely new functions, you can scale it in many different ways, and you can have the constellation distributed globally. You can do a bunch of different interesting versions, I guess, of the constellation, because it's taking its configuration and constantly being updated from a remote server. And so, yeah, we'll be talking more about these capabilities in the next couple months. But for now, const is really just a way of running a static Atmo application with a constellation of SATs, and it will become more flexible over time.
That's exciting. Thank you. Got one more from Denopink. Sorry about the typo. Denopink on Discord. In your opinion, what could or what would or should be the deciding factor between using Atmo or SAT in a given project?
Yeah, I would say Atmo is really designed for the central cloud Kubernetes version of the world, where you are deploying, a container, and that container is being horizontally auto-scaled, and you are kind of conforming to the current norm of microservices in Kubernetes or in the cloud. That's what Atmo was really designed to do. SAT is something that you should reach for if you are trying to run a service on, resource-constrained hardware, on something resembling the edge, whether that's, a Raspberry Pi in your closet, or, an edge service like edge functions. Or if you're running something, very simple that, you want a zero config server for, because everybody loves zero config. That would kind of be the distinction that I would make right now.
Fantastic. Thank you so much. All right. If there are no further questions, I think we can go ahead and call it a day. Connor, thank you very much for sharing and for demoing. That was really exciting. And yeah, let's start wrapping up for today. How was that, folks? I think it was super fun to be able to join in today and being able to share with you what we've been up to. Having that wonderful conversation with Philippe, showing you what's new with docs, and yeah, what we've been working on with Sat and Consti. So thank you all very much for joining. Thank you for watching live. If you're watching later on in YouTube, hello, future. Thanks very much for watching. And yeah, stay tuned. We'll do one of these every month. And yeah, see you around. If you want to join the conversation, always feel free to join us on Discord. That's, am I going to do this right off the top of my head? Chat.suborbital.dev. Yes, I did do it right. Let me put that into the comments there. Yeah, if you want to, oopsie. If you want to join us on Discord, feel free to. I should have planned this better. .suborbital.dev. There we go. Yeah, if you want to join us on the conversation, we are always around. Thank you so much for coming on today, and yeah, see you next time. Bye now.